Yeah. If you don't mind, and open your ISN book to the answers. If you haven't done them, we're going to kind of do them together. Okay. So a 52 kilogram skater. That's our mass, right? The next thing it says that it guides to a stop over a distance of 24 meters. 2.5 meters per second is my velocity. Where do I get that from?
Moves at 2.5 meters per second.
Very good. So it tells me that, right? So the first thing it asked me for is find the skater's initial kinetic energy. So the first thing I'm going to do is I'm trying to find kinetic energy. These are the formulas that we had yesterday. So I'm going to use this one. Kinetic energy equals 1/2 times the mass velocity squared. So what I'm going to do is I'm going to do 1/2 times 52 kilograms times 2.5 squared. So open up your calculator and do your math. I'm not going to tell you the answer. I'm going to check mine. When you get it, please call me and I'm going to come look. Yeah. Really quick on it. Fantastic. Ready? Yes. 162.5, right? Is what you got. So then the next one says, how much of her kinetic energy is transferred and performed, into work? So let's see what she has to do for work. So if we're doing work, which is the change in energy, kinetic energy final minus kinetic energy initial. I don't like any of those, but I do like this one. This is 1/2 of the mass times velocity final squared minus 1/2 of the mass velocity initial squared. So I'm doing 1/2 52 times 2.5, right? That's my final velocity. Minus 1/2 times 52 times 0, because she started first, and that's a 0. So let's see what you get. What'd you get, sir? Okay. What do you do this, Fred?
We gotta put 2 on top.
Oh, you've got squares? Yeah, I put them in there afterwards. I like, ooh. Mm-hmm. Yep, perfect. Perfect. Awesome. Okay. Looks like everybody got one good. Let's look at question number 2. Question number 2 says an 875 kilogram car, that's our mass, speeds up at 2.0 meters per second to 44.0 meters per second. What is the initial and final kinetic energy of the car, and how much work was done on the car to increase? So the
870 kilograms.
Yes, sir. So what you're going to do is you're trying to find kinetic energy again. We're using the same formula. 1/2 times the mass times velocity squared, which is 1/2 times 875 times 22 squared. See what we get. And if you'll change your mode to scientific for me on this answer, because this is a pretty good big one. I think that's going to fix you. Perfect. Right here. Yep. Get ready. Yep. 2.11 times 10 to the 5th. Perfect. All right. So now we have to find kinetic energy final. So for kinetic energy final, we're going to do 1/2 of the mass times velocity squared. This time we're going to use 44 for the velocity. Tell me what your answer is. Or show me. Because it doubled.
The only thing that changed the equation was 22.
Yes, sir. It's 44 now because it's doubled. Already saw yours, right, sir? Yeah, I already saw yours. Okay? What you got? Perfect. All right. Last one on this section. 3. So number 3 says a comet at the mass is 7.85 times 10 to the 11th. That's our mass. Hits the Earth at speed of 25 meters per second. Find the kinetic energy of a comet in joules and compare the work done on the Earth as it stopped the comet at 4.2 times 10 to the 15th. Energy is released and the largest nuclear weapon is exposed. Now, why did I change my velocity? Yeah, that's all it is. Just change it to scientific. Okay? So what we're going to do here is we're going to do 1/2 times 7.85 times 10 to the 11th times 2.50 times 10 to the 4th squared. So let's plug that in. Yeah, you got it. You got it, let me know. I'll come by and look. Yeah, perfect. Yep. Got it, Fred? No, nope, that's something different. 1/2, so 25 to, oh, did you just square the last part? Oh, hit enter. Just hit enter. Nope, he didn't. Uh-oh. Square that. Just do caret squared. There it is. That's it. Okay, babe? Write that down. All right, I'm gonna stop there for a little bit, let you work on your ISM book for a little bit more, and then we'll go to the next math one, okay?